Personalized item ranking is a crucial component of recommender systems, with pairwise ranking being a representative approach that optimizes ranking with user implicit feedback by constructing user positive item, negative item triplets. However, treating all triplets equally may not achieve the best effects, and recent works have assigned different importance scores to negative items, user item pairs, or triplets. Nevertheless, these generated importance scores are often groundless and hard to interpret, thus lacking transparency and trustworthiness. To address this, the authors propose the Triplet Shapley, a Shapley value-based method to measure triplet importance in an interpretable manner. Due to the huge number of triplets, they transform the original Shapley value calculation to a Monte Carlo (MC) approximation, providing a guarantee for the approximation's unbiasedness. They also adopt a control covariates-based method to stabilize the MC approximation. The authors utilize the Triplet Shapley value to guide the resampling of important triplets for benefiting the model learning. They conduct extensive experiments on 6 public datasets involving classical matrix factorization and graph neural network-based recommendation models. The empirical results and subsequent analysis show that their model consistently outperforms state-of-the-art methods. The authors emphasize the need for interpretable triplet importance in personalized ranking, as existing methods either focus on parts of the triplet or rely on heuristic approaches or black box neural networks, which lack transparency and trustworthiness. By proposing the Triplet Shapley, they aim to provide a more interpretable approach to generate triplet importance scores, enabling better insights into adjusting the sampling strategy and improving model performance. In the realm of recommendation systems, personalized ranking is a crucial aspect that significantly influences user satisfaction and engagement. The paper under discussion focuses on optimizing this process by leveraging triplets, which are sets of 3 items that play a pivotal role in model performance. The authors propose a novel method called Interpretable Triplet Importance for Personalized Ranking, ITIPR, which utilizes Shapley values to determine the marginal contributions of each triplet. This approach provides an interpretable measure of the importance of each item in a triplet, thereby enhancing the understanding and optimization of the recommendation model. To compute the Triplet Shapley values, the authors design a gradient descent-based Monte Carlo approximation method. This method offers a theoretical guarantee of unbiasedness, ensuring that the computed values accurately reflect the true importance of the triplets. Furthermore, the paper introduces an importance-aware resampling method aimed at supplementing high-importance triplets to previously constructed ones. This is achieved through a neural network module that predicts the Shapley value for triplets to be sampled, guiding the resampling process towards more informative data points. The effectiveness and applicability of ITIPR are demonstrated through extensive experiments on 6 public datasets, utilizing 2 matrix factorization-based and 2 graph network-based backbone models. These results underscore the potential of ITIPR in improving the performance and interpretability of personalized ranking models in recommendation systems. The authors delve into the concept of interpretable triplet importance for personalized ranking, emphasizing the relationship between triplet importance scores and the final recommendation model performance. They introduce data valuation, a method aimed at quantifying the contribution of data in algorithmic predictions and decisions. This approach highlights the limitations of traditional leave one out loop tests and the advantages of data Shapley methods. However, existing data Shapley methods are primarily designed for regression and classification tasks, with a lack of discussion in personalized ranking tasks. The authors formulate the top K recommendation task, where the goal is to recommend an ordered item set for each user, given the training item set and the non-empty test item set. They review the Bayesian personalized ranking (BPR) paradigm, which consists of 2 key components: triplet construction and pairwise training. In triplet construction, the authors formalize the triplet construction space, while in pairwise training, they contrast user-positive item pairs with user-negative item pairs to guide the model in capturing user preferences. This research paper explores novel ideas and significant findings in the realm of personalized ranking, providing insights into the importance of data valuation and the application of data Shapley methods. It also addresses limitations and assumptions, paving the way for future work in this field. The paper delves into the utilization of Shapley values in personalized ranking, aiming to provide insights into which triplets predominantly influence the ranking performance. It defines the triplet Shapley as interpretable importance, based on the direct influence of each triplet on the final model performance. The authors also describe how to approximate the triplet Shapley using Monte Carlo approximation and a gradient descent-based truncated Monte Carlo approximation for efficient computation. Furthermore, they discuss the issue of variance in the approximated values and propose the control variate method to stabilize the triplet Shapley approximation. Interpretable triplet importance for personalized ranking leverages an algorithm for gradient descent-based truncated Monte Carlo approximation of triplet Shapley values. This method estimates Shapley values using a modified gradient descent algorithm and control variates to reduce variance. A key aspect is selecting the optimal constant, c, to minimize estimator variance. The authors introduce a modified version of gradient descent, denoted as omega asterisk operator, which can clearly distinguish the contribution of each triplet. This modified gradient descent algorithm can obtain the accurate value of VTS asterisk operator, U, I, J, for all triplets within an acceptable computation budget. Furthermore, they discuss importance-aware triplet resampling, aiming to exploit the data potential in the resampling process. This approach is crucial for enhancing the efficiency and accuracy of personalized ranking models. Optimizing recommendation model training with triplet importance prediction. Enhancing recommendation model training requires leveraging the entire triplet construction space. To achieve this, a neural network model, triplet importance prediction, TIP, is proposed to learn predicting triplet Shapley values for unsampled triplets. This enables the estimation of the importance of each unsampled negative item, which guides the resampling process. The sampling probability of an unsampled negative item is modeled based on its estimated triplet Shapley value, ensuring that more informative triplets are selected. The overall learning procedure involves three key components: approximating triplet importance using TIP, importance-aware triplet resampling, and triplet importance-weighted pairwise learning. This integrated approach optimizes the training process by focusing on the most informative triplets. The authors provide a comprehensive algorithm outlining this procedure, which is validated through experiments on several public datasets. The results demonstrate the effectiveness, applicability, interpretability, and time efficiency of the proposed method. The TIP model's ability to predict triplet Shapley values enables the recommendation model to learn from the most valuable triplets, leading to improved performance and enhanced training efficiency. This paper conducts a comparative analysis of various personalized ranking models across 6 datasets: Amazon Books, Amazon CDs, Gowalla, Yelp, ML20M, and MLLatest. The models tested include BPR, WBPR, AOBPR, PRE, TCE, RCE, TCE-BPR, RCE-BPR, TILUI, TILMI, and ITIPR. Evaluation metrics used are, and the results show that the ITIPR model outperforms all other models across all datasets, with significant improvements in, and this suggests that the ITIPR model is highly effective for personalized ranking tasks. The paper also provides insights into the performance of different base models, such as MF, NOI-MF, NGCF, and LIGHT-GCN, which can guide future research in this area. This research paper presents the development of an interpretable triplet importance framework for personalized ranking, named ITIPR. The ITIPR method aims to enhance recommendation performance by modeling the importance of triplets, which consist of a user, a preferred item, and a non-preferred item. The authors propose 2 key components: triplet Shapley-weighted pairwise learning and triplet Shapley-aware resampling. These components are designed to learn from user preferences and improve the accuracy of recommendation systems. The ITIPR framework utilizes the concept of Shapley values, a game theory approach that distributes the total gain among players based on their individual contributions. In this context, the Shapley values are used to determine the importance of each item in a triplet, providing insights into how users perceive and interact with different items. The authors demonstrate the effectiveness of ITIPR through experiments on real-world datasets, showing significant improvements in recommendation performance compared to baseline models. They also provide an in-depth analysis of the interpretability of the ITIPR model, highlighting how it can offer insights into user preferences and item relationships. The ITIPR method has potential applications in various domains where personalized recommendations are crucial, such as e-commerce, music streaming, and online advertising. By understanding the importance of triplets and utilizing Shapley values, researchers and practitioners can develop more accurate and personalized recommendation systems that better cater to user needs and preferences. In the realm of recommendation systems, Bayesian personalized ranking plays a pivotal role. To enhance the training of recommendation models, researchers have introduced interpretable triplet importance for personalized ranking, a novel approach leveraging Triplet Shapley values. This method measures the contribution of each triplet to the model's performance, providing a crucial component for interpretable model explanations. The authors propose the concept of Triplet Shapley value, which represents the importance of each triplet in the model's performance. Experimental results on 6 datasets demonstrate the efficacy and efficiency of this approach, significantly improving the recommendation model's performance while providing interpretable explanations for the assigned importance scores. To address the issue of variance in estimating Triplet Shapley values, the authors employ a control-variates-based stabilizing strategy. This strategy reduces the estimation variance, making the rankings among different triplets more stable and discriminative across different trials. In terms of time complexity, the authors compare the training time of various methods under different base recommendation models. The results indicate that the proposed ITIPR method is competitive with previous methods, such as TILMI, in terms of time efficiency. The paper highlights the potential of the proposed approach for enhancing recommendation model training and providing interpretable explanations. Future work will focus on efficient computation for large-scale data in practical applications, addressing the limitations of the current approach. It seems like the provided content is incomplete. Please provide the complete text, and I'll be happy to refine it according to the guidelines. The paper on interpretable triplet importance for personalized ranking employs several key notations, summarized in Table 4. These include symbols for users, items, user-item interactions, embeddings, triplet construction space, sampled triplet set, and triplet importance weights. The paper also reviews 2 categories of recommendation models: matrix factorization, MF-based models, and graph neural network, GNN-based models. MF-BASED models, such as MF and neural matrix factorization, NOI-MF, factorize the user-item interaction matrix into 2 matrices representing user and item embeddings. The predicted user-item interaction is computed as the inner product of the user and item embeddings. GNN-based models, such as Neural Graph Collaborative Filtering, NGCF, and LightGCN, leverage the power of graph neural networks to learn user and item embeddings. NGCF considers user-item interactions as a bipartite graph and uses GNN to propagate information between connected nodes. LightGCN is a simplified version of NGCF that uses a simpler aggregation function in a normalized adjacency matrix to prevent bias towards highly connected nodes. The paper provides a proof for Theorem 1, which involves recalling equation 4 and setting C equals 1, dt, to derive the transformation. This supplementary information is essential for understanding the proposed framework for interpretable triplet importance in personalized ranking. The review of MFBASED and GNN-based models provides context for the applicability and robustness of the proposed framework. The proof for Theorem 1 provides additional technical detail to support the paper's claims. The paper explores the application of Shapley value in machine learning models, with a particular emphasis on time complexity and interpretability. It introduces a novel approach to efficiently compute the Shapley value for each feature in a machine learning model, making it more practical for real-world applications. The authors provide a theoretical analysis of the time complexity of their proposed method, demonstrating its efficiency compared to traditional Shapley value-based methods. The proposed interpretable triplet importance method for personalized ranking is supported by supplementary information and experimental details. 6 public datasets, including Amazon Books, Amazon CDs, Gowalla, Yelp 20M, Yelp Latest, and ML Latest, were used in the experiments. These datasets have varying numbers of users, items, interactions, and densities, as presented in Table 5. The computational complexity of the original procedure for Triplet Shapley approximation is O, dt. However, by employing Monte Carlo approximation and truncation operation, the complexity is reduced to O, v, squared, in practice. This reduction allows for significant time savings when deploying the method on multiple machines, as the Monte Carlo process in algorithm 1 is parallelizable up to the number of interactions. Furthermore, dividing items into coarse groups based on property similarity can reduce time consumption while maintaining accuracy. The supplementary experiments section provides full descriptions for the 6 datasets used in the experiments. Each dataset is pre-processed to ensure that users and items meet certain filtering thresholds, such as a minimum number of reviews or ratings. These datasets are sourced from various online platforms, including Amazon, Yelp, Gowalla, and Movie Lens.